All right, welcome students to Omaha Data Science Academy. This is the Cloud Solutions and API Integrations class. I'm Jeremy Bergman, the instructor. And tonight's lecture is on data security and real-time analytics. So data security, general principles of data security in terms of data engineering. And then we will apply those to security protocols within Microsoft Azure and see how those fundamentals relate to Microsoft Azure. We'll also do a deeper dive of real-time analytics. We will take a look at Azure Streaming Analytics in the context of Microsoft Fabric and those components and some of the things that we learned in class 5 or class 4, the data processing class. We'll dive just a little bit deeper into those. So not expecting any of this for the class project, but there will be a couple questions here about it on the final exam, just to take a note of that. So as I said, always just making the data engineer familiar with the services and tools that are available. And we'll dive a little bit deeper into these two things tonight. Okay. So really this class is two of the major topics out of the different things that we really didn't cover in depth in this class. It's a little bit, not quite a catch-all tonight, but some of the things that we will cover is security, so role-based access and access lists in Microsoft Azure. We'll take a look at real-time intelligence. We won't actually take a look at Azure functions, but we will do this in terms of Microsoft. A little bit about Microsoft Fabric, a little bit of background and what's available there. You'll see a lot of similarities between what we have seen in the Azure Data Platform and then Microsoft Fabric's complete analytics platform. Some of the other topics we won't cover quite as much as Azure performance tuning and optimization. So some of this has to do with configuration, and then some of it is just writing better code or designing better pipelines and so forth. A little bit outside of the scope of this class, the scope of this class is really to get in a 4-week class to get future data engineers that's familiar with a data engineering platform and get their hands, on the different aspects, whether it's storage or data processing, analytical processing, creating notebooks, pipelines, building machine learning models and deploying machine learning models, or some other critical aspects like we're going to cover tonight. Some of it's just pretty hard to fit within a 4-week window. One of those would be diving really deep into performance tuning. Not going to cover monitoring tools too much other than noting that Azure Monitor does exist to be able to monitor certain events within services, whether it's hit certain metrics like CPU thresholds or cost. You could even do Azure Monitor. You can monitor the costs that you're racking up. So you could set a baseline and send you an alert. Do logs, tracking logs and any changes within the system or within logs, being able to detect those. That's what Azure Monitor would do. We weren't able to really dive deep into the big data technologies other than knowing that they exist. I do that because a lot of them are really kind of special use cases, as I talked about, especially the NoSQL technologies like graph DBs or document DBs or different types of table DBs. And then with big data technologies, not processing too much big data, not processing big data in this class, but it's something to do here in this class in the future. Then data redundancy and recovery. Not really going to cover that too much other than in the storage class, we think that we're familiar with that being one of the aspects of data engineer's role, maybe class 1 and then class 3 a little bit more in storage, being able to have redundant storage across those regions that we set, being able to recover it, kind of like disaster recovery, or if there's some type of data breach, being able to recover from the data breach. So the last few topics we'll cover some security topics, so some general principles applied to Microsoft Azure. We'll look at the real-time intelligence module in Microsoft Fabric and see those similarities between what we've been learning in that platform. We won't cover Azure Functions here either. We do, instead of doing Azure Functions is like being able to create, like, what would I say? You could create literally like functions in Python and just run compute on these functions to be able to perform certain operations. It can be very useful when you're utilizing big data and you want some type of function that is very lean and very fast. Azure Functions can do that for you. In this class, we focused on just using notebooks. We focused on using notebooks for data processing and analytical processing. So that's another topic that you could potentially dive into. So really, it's a matter of like choosing here in 4 weeks in 8 classes or 7 classes, like what's the most important topics to cover in cloud. And we'll be changing as we create a fundamentals of data engineering class and then what we teach in this class. So stay tuned and potentially drop in for future classes. Okay. So how is this current class structured? So I've mixed in a couple of video demos in hour 1 and hour 2 and hour 3. So hour 1 and 2 is really going to be about real-time intelligence, being able to do monitoring and alerts out of it, and then seeing Azure Stream Analytics in action. May not take the whole 2 hours, probably likely won't. It's a fairly decent sized lecture. In hour 2 to 3, we'll cover data security principles, especially related to the role of data engineer. We'll introduce everybody to role-based access control and access control lists. In Azure, they have 2 different functions. Knowing how to be able to apply those in your role as a data engineer can be valuable. And then we'll do video demos of these security principles and how you apply them in Microsoft Azure. So those are the 2 topics we're going to focus on tonight out of the remaining topics that we didn't cover in depth in this class. Well, Microsoft Fabric, we talked a little bit about this in class, and last time I taught this class, I actually taught Microsoft Fabric because it's like an all-in-one cloud-based data and AI platform. So this is one of those platforms like we saw with Databricks, or the promise of Azure Data Services is that it's like highly integrated and everything's there for collaboration between data analysts, data engineers, and data scientists, all in one platform. There's a data lake inside of it. It's called One Lake, but it's really Gen 2 storage. It's the same thing. Powered by AI, you can use generative AI within your projects. You can do the same with, you can do the same with Azure products too, or the Azure Data Platform products also. One of the nice features it has is it has this data activator that takes actions when patterns or conditions are detected in changing data. So that's related to that Azure Monitor, but they have their own module where you could set specific rules or thresholds or conditions or statistical variability, to be able to detect certain things and alert you to those. So the reason why I didn't teach it for this class is, come to find out, once you start going through it, the platform's not really ready for prime time. There's like a lot less configuration to do, but the integration between all of these still needs quite a bit of work for it to be like a fully integrated platform. We just ran into a ton of challenges trying to like connect services or write code and stuff like that wasn't quite worth it. I would keep my eye on Microsoft Fabric, because Microsoft Fabric tends to release first generation products that really aren't very good. And then the second generation is good. Then the third generation, they try a bunch of new things that aren't very good. And they iterate on it until you have something that's usually products that are pretty decent. That, or now they buy competitors like Databricks or something. If Databricks ends up better, then so be it. But I do have some lectures and lecture video if anybody is interested in those from the previous class. They'd also be out there on Omaha Data Science Academy if you wanted to see through them. But we ran into a lot of challenges. And you can see like it has the same things as our data platform. So it has Power BI, Data Factory. Synapse Data Engineering is just the same as Synapse Analytics that we learned in recent classes. And the Synapse Data Warehouse is that SQL Data Warehouse. The data science is just Azure machine learning. And the real-time analytics piece, which we'll dive deeper into, is it's the I can't think of the name of it at the moment. Real-time analytics, but that's not what it's called. Okay, stream analytics. That's right. So this is really stream analytics, but they like rebranded it inside of Fabric and trying to connect all of it. So I think they're listening to people as far as like the platform being kind of hard to configure and trying to make it into this whole one experience that takes less configuration, but we still have some work to do. We still have some work to do on it. As we found in this class, configuration can be, and maintenance can be one of your biggest major headaches of being a data engineer or systems engineer, and then keeping them running. The less of that, the better. That's also the promise of the cloud. Okay. So just introducing Microsoft Fabric and the things that we're going to cover tonight, and some topics that we didn't dive so deep into in this class. But one of the topics we will dive deeper into is the real-time analytics using Microsoft Fabric. You see the real-time intelligence. You see a lot of similarities here. You have like an IoT hub. You'll have your stream processing. You have your KQL language. And then you still have like your database and your processing and everything. So still the same thing. They just kind of repackage it and rebrand it in Microsoft Fabric. So the key components are processing, being able to process data in real time, or at least really close to near real time. And maybe it's also a high volume of data. And then in real time, being able to analyze it. So using KQL, that language, you'll see a little bit of that in action. A little bit different than SQL, specifically made for real time and streaming data sets. And then being able to monitor the data for certain real time events, and then being able to act upon it. So acting upon it would be like real time alerts. We'll see some use cases where real-time alerting is really valuable. You can think about it as, especially if it's like high impact in real time, like the faster you mitigate it, the less damage you would potentially do. Okay. So I gave a pretty good overview there, overview of real-time intelligence. Fundamental concepts of real-time analytics and its significance in data-driven decision-making. Fabric packages it into this real-time intelligence, but as I explained in our data, in Azure, in the Azure data platform, we have all the same resources. They've just packaged it in this real-time intelligence. So here we'll do an overview of streaming analytics. We'll do a live video that demonstrates real-time data pipelines within Microsoft Fabric. So I have videos tonight for everyone to watch instead of doing hands-on demos. We'll look at how you ingest real-time and ingest and process real-time data. So learn how to effectively ingest real-time data. How do you bring that in and process it? That's what it means by ingesting. Ingesting would be like data processing in the cloud using Azure Data Factory. Maybe you're ingesting huge amounts of data and moving it, or maybe you're ingesting real-time data or just data lake data or analytical data. Maybe you would do that in Synapse Analytics. You have a bunch of different tools for ingesting data or taking that in, and then being able to process it in real time. There are tools designed specifically for that in Azure. One of the good things is that you can implement monitoring and alerting features in real time, understanding how to integrate that monitoring and alerting functions to ensure prompt responses to data changes. So usually it's costly for organizations to do things in real time. It takes a lot of computing power. It takes a lot of optimization and efficiency and just engineers' time to be able to do it. Sometimes it's not super practical without the tools, being able to have the right tools to do it also. But now the cloud has some specific tools to help you with those challenges. And then we'll see specific use cases when real-time analytics enables them to respond swiftly to market changes. So there are sometimes reasons why it's valid that an organization needs to respond to things in real time. That happens. But my point is, the point that I was making is that oftentimes it's very costly and difficult to engineer, maybe almost impossible to engineer without the right tools. And the cloud gives you some of those tools to be able to do it much more effectively. Sometimes, won't go into it too much. Sometimes operations, I want to know about things in real time. But the important thing is, like, not everything has to be in real time. You have to also say, is it something that you can action on in real time? So they made a good point about ensuring prompt responses, that it's actually alerts that you can action on or do something about in near real time. Then the value's potentially there for it. Sometimes people will want to monitor things in real time that aren't really actionable. It just becomes sort of a waste of computing resources and time and money. So it's always the balance of being a data engineer and helping inform others of what a potentially good solution is and why things are a good solution, or maybe why you should potentially not do some certain things. But with the cloud, you can do a lot more. Okay, so an introduction to real-time intelligence. We're going to understand some of the key concepts and applications of real-time intelligence. So this is a basic pipeline. You collect real-time data. It's a whole bunch of data feeds. Maybe it's streaming data feeds. It's IoT. Maybe it's social media data and so forth. The second part is how you process that data or ingest it. So you ingest it, you calculate, you do your calculations on the real-time data. Oftentimes you aren't storing all that real-time data as it lies, because that'd be massive amounts of storage. It may not even be practical to store all of it. So oftentimes you do some type of summary calculation on it to get it down to where you say, yeah, now we're taking valuable information out of those real-time streams. And then you transform them for analytical purposes, and then you process it. Maybe your process or rules-based processing, or it's some type of machine learning model or analytical function that detects outliers potentially. So you're processing it in near real time. So you do these things, calculate and transform and process, all within matter of milliseconds, and then augment the data that you need to turn it into information for visualizations and dashboards and some ad hoc querying, near real-time ad hoc querying. All right, so real-time analytics, that describes that. This is generally like the pipeline or the process that you would follow for real-time streaming data. So what is real-time analytics? It refers to the process of continually inputting data and analyzing it immediately to provide insights that can drive timely decisions. That's what we do, is like you can analyze it immediately through calculations and transforming it and processing the data. So not that much different than we do in pipelines. They're just special tools to do this in real time. So it's important to modern business. Talked about a little bit on the last slide, but in fast-paced environments, real-time analytics enables organizations to respond swiftly to market changes, optimize operations, and enhance customer experiences, which is true. In near real time, you recognize that a customer has some type of behavior on your website, and then you want to deliver them an ad really fast based on what they're already doing. There's potentially use cases for it. It's always being careful, I feel, is like that it's actionable change, it, or like the changes actually make an impact, or if you're being alerted to it, or like that these things are actually actionable and making an impact instead of just doing it. So real time versus near real time versus batch processing. So real-time processing delivers insight instantly. Near real-time offers slightly delayed insights. Batch processing involves analyzing data at scheduled intervals. So the way I think about this is literally as it's happening. Maybe near real-time, maybe it doesn't necessarily require this intense processing, but we're still evaluating it in some way, like close to real time. Maybe it's within seconds of something happening. And oftentimes that's okay. Like, it's really a matter of, does this need to be like actioned immediately, or is a few seconds okay? There's sometimes different tools that you can use for those. And then batch processing is something totally different. So that's what we're doing in the class project, is that at some type of interval, we're taking from the REST API just a data pool that we update with our current data. So batch processing is typical in like your data warehouses or your analytical data stores, where you're processing data. Maybe it's a couple times a day, maybe it's once a day. Oftentimes data warehouses get information and they look back at the day before to see what happens. And that can be perfectly fine too, especially if you're extracting huge amount of data out of systems constantly. Maybe you want to do that processing overnight and have the results in the morning, and that perfectly meets your needs. So understanding as a data engineer, near real time versus batch processing, and the differences and the use cases is something always to keep in mind when you're thinking about solutions. And then business use cases, so application of real-time analytics. So here's some of the use cases. So the one I always think about is fraud detection, how amazing that is. That's literally something like, if you can action on it right now instead of a couple minutes later, there's like immediate impact to it by doing it real time. Customer behavior in real time on an e-commerce website. There can be instances where you want to give them an ad or do something. Maybe they're at checkout and they've done something. You want to be able to see that event and do something like right away before that opportunity is gone. Supply chain optimization. So often there's like a concept of it's like on-demand inventory. So I can't think. I worked so long in supply chain and I can't think of it at the moment, but basically it's like you barely hold any inventory. It's always like near real time inventory and being able to optimize it as people buy things. And then allowing businesses to make decisions proactively. So I'd say that one is encapsulating of just all of business intelligence and data analytics, is allowing businesses and the people within it to make informed decisions from data, whether it's real time or near real time versus batch processing. So I keep preaching it, but I don't know how many times I've been told like we needed or been advised by somebody in business to say, yeah, we need to like see this when this happens. Like it has a huge impact, but you really have to sit back and consider the use case and the importance of having it near real time versus like seconds later versus a couple times a day. And usually the key one is, can you actually do anything with that information that you're gaining? What is like the outcome of it? Because it's still expensive to do things near real time, even if you have the cloud. And then maybe justifying the cost too. Just because something's important, maybe doesn't justify the cost of doing it. So as a data engineer, always thinking about those things when you build solutions. Okay. So importance in use cases. Why is real-time analytics analysis important? Kind of just restating what we learned on the last, or talked about on the last slide, is that fast-paced environment helps organizations and individuals to act immediately on insights as they occur, given that those actions or insights are actually actionable immediately and actually are important. Some of the reasons why it's important: timely decision-making, customer experience, operational efficiency, covered all of those. Competitive advantage, so this one's kind of interesting. So of course you have Uber and Lyft, and then being able to like do routes or see where people are in real time. That's an important use case of real time, using real time data. And any like milliseconds advantage you can get over your competitors in that, maybe that's a ride for Lyft or Uber instead of Lyft. So if you're directly competing with the customer that's doing that, could give you a competitive advantage. Risk mitigation, we talked about fraud, scalability and flexibility. Maybe you can make your systems and websites more scalable by efficiently processing data in a more effective manner. Enabling IoT applications, so like smart thermostats, taking in information and then doing that, like adjusting your thermostats in real time. So I was listening to an ebook. One of the interesting ones is they created these IoT sensors for this type of toaster. I forgot what type of toaster it was, but it's constantly feeding them information, and then they could make smart adjustments on the fly based on how that person used the toaster, and then how other people use the toaster. Some of the challenges I had were some of the outliers of people who like to make toast really weird, but they could adjust to like that person's behavior and other person's behavior through IoT or smart thermostats. IoT, another one, is self-driving cars. Being able to, they could actually learn from like accidents. If self-driving cars had accidents, you could actually learn from that and correct some of the behavior behind it, and do things in near real time or basically real time. But imagine that's really hard, because if you have millions of self-driving cars, like how many data points are coming in at like exactly the same time, literally trillions. It would be from all of these different sensors. That's probably really the biggest challenge, and then the infrastructure to do it. But different discussion, but an interesting one. And then public safety and emergency response, being able to get that information if it's a life-saving, like time is critical when it's life-saving. They say every second counts, like literally. It's where real-time data can be useful. The challenges to it is really like having the robust infrastructure for it, having the high-speed networks and powerful analytical tools. Cloud helps with that, cloud like Azure. Being able to manage that data and handle that large amount of data, you often take special tools. You can just do it in a relational database. You would run into just bottlenecks and major challenges, and transactions would start colliding in a relational database. And then having this skilled workforce, the people who have the expertise to do this real-time data processing. That's why these big data engineers are really rare, because it's really a pretty specialized use case or like specialized skills. Well, specialized use cases, but really specialized set of skills to process and ingest this type of data. Most people in most use cases they aren't really that critical in real time, but if they are, having the skills and expertise, they'll set you apart. Already mentioned these use cases over here, but e-commerce one, tracking real-time customer behavior. There's a lot of websites that do that. They give you an ad or pop something up as you're browsing the website or putting something in your cart, or just trying to improve your customer experience on the website. Maybe they see like others have done, like Amazon, like others who have bought this may also like this. So maybe that's not real time, but things like that could detect like your behavior on the website in real time and then offer you certain things. There's a lot of e-commerce websites that do that now. So there's still quite a few use cases. Often they're kind of like specialized use cases with specialized skills, but that's why we learn about these things as data engineers. Okay, key features of real-time analytics. So some of the essential capabilities just in the Microsoft data platform for effective real-time data handling. So we have the real-time monitoring and alerts. Set up real-time monitoring alerts to track data quality, processing health, pipeline performance. You can do all of this in Azure Monitor. And Fabric has their own, that data activator, I believe it's called, in Fabric. They have their own, but you can also do all this stuff in Azure Monitor. So we did briefly mention it in this class, what you can do with Azure Monitor. But you can then you can send those alerts and notify people of specific conditions or anomalies if those happen. So anomaly detection, just talked about that. You can use Spark to be able to detect those anomalies, its outliers. That's often what fraud detection is. It's some very much outlier compared to the normal transaction, and doing that in real time. Or identifying different patterns of unusual behavior, or even systems or performance monitoring. So is there some behavior in the system that is way outside of the norm? Maybe that's like some breach or some hacker or somebody broke in and they're using the system in a very weird way. So real-time anomaly detection is a key piece. Real-time analytics, of course, stopping a hacker if they broke into your system in real time, being able to detect that behavior. That just, the more you can do that, the more you can mitigate the problems that you have by allowing them in the system longer. Real-time data transformation and enrichment. So being able to effectively transform and enrich it for analysis. For example, transforming IoT sensor data for analysis capabilities. So there's a demo that will show you how they take IoT data. I forgot if it's in this one or not, but I originally saw a Power BI demo years ago that they were doing the streaming data, the IoT stream, and you could visualize it in Power BI in real time. So being able to like take that data and transform it into like almost like metadata information, and then being able to see that in real time is pretty cool. And then having the real-time insights and reporting in Power BI, be able to do that. So in any platform, it's going to look something similar to this. And then you'll have some type of visualization tool. Maybe it'll be built in to the whatever platform you have. Like we saw with Data IQ, you can build your own dashboards in Data IQ. But Power BI is good for it. I would say it's nice and lean. You can also do it in something like Tableau. You could connect Tableau to a real-time data processing. I am nearly certain that you can connect it to the K-queries and in Azure, so that KQL language in the database, so that you can see like the transformations that it's doing in real time. I've never done it, but I'm pretty sure that's one of the connectors. And I know BigQuery for Google is, and BigQuery is like the same thing as KQL. But that's Google's version of like the real-time data processor. So all these platforms will have something similar, but that's the key features of it. This one's just Microsoft Fabric, but all of them will be fairly similar. Okay, so key components within the Azure ecosystem. And this is specific to Fabric, but we saw the similarities between Fabric and what we've been learning in this class. So I put two of these in green and red. So red is really the ones I think about is what you use specifically to ingest real-time data. And some of these technologies like event hubs, IoT hubs, and Kafka for instant processing and ingestion. And then you have these hubs that help you transform like events and event ingestion or IoT data coming in from sensors. And then your Data Explorer and KQL to be able to process that data in real time. Be able to analyze the data in real time or near real time. Highly scalable, fast and highly scalable for data exploration for large data sets in real time. So I put these other ones in green because they're kind of like complements to these red, the real-time streaming data. So Spark, we learned about Spark and Spark notebooks. We use that. We use that in Databricks, and then we use it in Synapse Analytics. But Spark can help with some of that processing, especially with machine learning, allowing you to deploy scalable machine learning models directly within the platform. There are some times where maybe you would use Spark alongside your real-time data processing. If you have just a bunch of data coming in real time, perhaps you would also use Spark to be able to process some of those big data sets, because it has the distributed computing that allow you to break it up into parts and process it even faster. And then Power BI will allow you to visualize those out of this in real time. So all these tools obviously work together, but I think of these as the main tools. the red ones. And then Spark, machine learning, and Spark and Power BI as being the complementary tools for real-time analysis. Okay. So Fabric, talking about Fabric's real-time intelligence and capabilities. So we have all these things that we talked about: event ingestion, real-time analytics, real-time dashboards, and triggers, and event-driven actions. They also have real-time AI. Or they like to throw, whenever you can throw AI into things, your interest for it goes up. But I haven't used it in there yet, and I have to see if it's ready. Probably not ready for prime time, but anyway, it does have these capabilities, all these capabilities. Robust tools for real-time analytics, including KQL database, event streaming, real dashboards for visualization. That's the KQL database. I keep talking about that. That's like a language. It's a querying language. Think of it similar to SQL, but it's not for relational databases. It's really for processing data sets in real time. So streaming data is often like ones and zeros. It's bits or bit strings. And so is IoT data. Being able to take that data in and process it was like down to that level, or nearly down to the bit level. KQL would allow you to do that and then summarize the data, also process and summarize it. You have your event streams. It facilitates ingestion of streaming data, making it easier to capture and analyze data as it flows in real time. Those would be like your event hubs, your IoT, or your event stream IoT, your events IoTs. So you can have real-time dashboards, and then you can do real-time analytics in Synapse. So Synapse real-time analytics involves various data sources, comprehensive analysis, supporting advanced analytics and machine learning. This would be where you'd supplement Spark with it. So then here's a graphic. So the green is the capabilities. They're across all of these different functions within Fabric, which are very similar to what we learned in our platform, in our Azure data platform that we learned about. And then you can do things like real-time hub, and you can often store it in a data lake. So after you process the real-time data, maybe you decide to store it in data lake for future use. That would be also valid to do that if you had the right use case and reason to do so. Okay. So real-time systems. So key components of the real-time systems are those event sources, the ones that are generating all that information, like IoT, application logs, transactional data. So things that are coming out of systems at basically real time. Social media feeds, system metrics. So system metrics might be like your RAM or your CPU. So like, if you did Task Manager on your computer, you could see CPU, memory, disk, and network in real time. Where that's valuable is, I think I gave this example at some point during class, but I know someone who works at Airlight Plastics. So they, as a company, have all this machinery with different sensors on it, IoT sensors that take like the temperature of the machine or the process, like wattage, like how much work it's done in the last 10 minutes or 50 minutes or hour, and all sorts of different like threshold calculations that measure the health of the machinery. And like being the faster that you can do that and like generate an alert and say there's like an air condition, the faster you can shut that machine down, like you could potentially save hundreds of thousands of dollars on that machine instead of the machine breaking and then having to get a new one. So it's like a huge system metrics. You can monitor other systems, other servers, or a whole bunch of servers in real time, be able to do that and action on it. The processing engines like KQL are optimized for handling time-sensitive data. It's a key component. So not how you just obtain it and ingest it, and like how do you process it? It's using KQL in Azure. And then storage solutions. So you can store it in a thing called a KQL database. It has data management, hot caches for recent data, and so forth. This would be expensive to store it in KQL because of it being near real time and high performant. Maybe you could take it offline, store some of it in data lake and process it later. So maybe you want to capture some of it in real time for whatever reason and do some processing and alerts. But then maybe you want to store some of that data for retrospective analysis or for other purposes. Maybe it's not in that KQL database for immediate analysis, real-time analysis. Maybe you store it somewhere else. But the storage solutions in near real-time are helpful. As far as long-term data handling, I don't know if I would store streaming data in this for long-term, but of course that's up to the engineer and how it's needed. Right. So real-time processing patterns, so key techniques in streaming analytics and data transformation. So what is streaming analytics? It's continuous queries and analytics to process data in real time. And then you have all these different processing patterns. You have window functions that you may calculate over it, or different aggregations. So window function is just like you would do in Tableau. Maybe you go from the first date to like the next 30 days. You do a 30-day moving average. Really common with process or real-time data to summarize it. You can do other types of data transformations. You can do some in-stream processing, so handling data as it arrives for immediate processing and minimum latency. Maybe you probably aren't likely going to take all the data. It's like some type of summary or aggregation of it. And then you can apply different algorithms or thresholds to it, like pattern detection, anomaly detection. And then you can do some enrichment of the data, enriching it for analytical uses or format or converting the formats and validating the data. So quite a bit you can do from processing perspective. And then here's kind of like the process for setting up a real-time data pipeline. So if you had the objective of setting up a real-time data pipeline using Microsoft Fabric to enhance the real-time capabilities, you would first ingest the data through Event Hub or IoT Hub to facilitate that continuous data flow. Then you would set up a pipeline. So you could process some of this data in Spark. You could process it in KQL to create that robust data pipeline for that data that just continually comes in. So since you can use Spark SQL for filtering some of the data in real time, I don't know if that would be necessarily the best choice. You could use KQL to do that and Spark to do it in near real time. But there are things with it's just a ton of data. Spark may help you along with the real-time tools. Then you could aggregate real-time data streams, to summarize data and view the ongoing trends and patterns. So you aren't capturing all the data. You're just capturing the real-time data that you need and processing what you need for your use case, because collecting all of it and storing it and processing all of it can be a huge cost. You just want to process what you need out of it. But then the last step, if you're doing machine learning, that might be where you use Spark ML to retrain and update your models in near real time. So as these observations are coming in, you can continue to apply the machine learning models. You can update the models, or maybe you're doing some fraud detection to find outliers, and you did a machine learning model to do that. You can potentially do that in Spark ML in basically close to real time. I had to take a quick drink there. A lot of talking. All right. So there's an alerting framework you can create out of all this. There are all sorts of different types of alerts. You could do this by the monitor tool, the Azure monitor tool, or within Fabric, that data alerting tool. So you can do metric alerts based on thresholds. You can do log-based alerts to identify unusual patterns. You can do custom KQL to create queries and see when certain events occur. You can use a number of different ones of these if multiple conditions happen, and then various thresholds and time windows, frequency of alerts. Severity of alerts are important. So even if you're in IT doing systems, you don't necessarily want to just respond to every single alert that could possibly be generated. That could be tens of thousands of them during a day, and it's impossible to respond to all of them, and the brain just kind of tunes them out. So having severity levels and their urgency is actually like just as important. And then what's the action item on it? So being focused on the things that are the most important, and then being able to action on those based on the alerts most effectively. And maybe depending on the severity of alert, you get an email notification or you get a webhook to like your cell phone to tell you that you need to do something. And then you could use Azure functions to build functions, scalable functions, and logic apps. So just another way you can set it up, and we're almost done with real-time analytics. So another way you could set all this up is this would be like the processing, real-time data, real-time analytics processing. So you do the KQL for query monitoring, and they have a little use case down here. So utilizing KQL query to monitor CPU usage in real time and focusing on like spike events in the last 5 minutes. Maybe it's by a certain threshold. I know in the past I've taken a look at servers, and anytime they went above 90% utilization, it'd like give me a little warning. And then like every couple minutes, if it was still there, it would do the same thing. And then I'd go in and look at it. Then you could create those alerts from it. And having the level of importance is really important there. You can configure alert conditions, like under which alerts should be triggered, the conditions under where they should be triggered. Sometimes it's just a warning. Sometimes it shouldn't actually really be triggered. Or sometimes it's just a one-time event that doesn't happen again. That being able to track those is important, but maybe it doesn't warrant an alert to be triggered. Setting up appropriate notifications, and then testing that functionality to make sure it's not crazy and it's a reasonable alert. You can set up just too many alerts. People lose their minds over it. Mostly they just start blanking them out, really. Or You set up alerts and then they don't do the jobs that they're supposed to. They just count on the alerts. So there's a human element in all of it also, to be able to set up alerts that are most effective. But being able to do them in real time and Azure is really powerful tool to use carefully and think as a data engineer if it's really like, is it really something that you should do, and having a reason why for it or against it and building it appropriately. Okay. So here's a real-time intelligence demo that I have. So this is a yellow taxi real-time data demo. This is like one of the most popular ones with Microsoft and Microsoft Fabric, using real-time intelligence and Power BI to be able to visualize traffic patterns in New York City. This is a famous one. It's New York City's yellow taxi fleet, which is monitored by Taxi and Limousine Commission. So data includes information about taxis in the city, typically including details about their position, where they're available to pick up, passenger count, and even estimated arrival times. So really similar to like that Uber versus Lyft discussion or that we talked about a few slides ago, and being able to do that in real time. So the data is transmitted via REST API that provides access to live location and status information about yellow taxis. So sometimes you may have a streaming API or some type of other API. So for this transactional data, I'm guessing REST API is good enough. Maybe they have a different database under the scenes or doing some real-time processing some other ways. Maybe it's not a relational database behind the REST API, but the REST API is good enough for all of that transactional data that's coming in. So it can allow developers to receive that data. Part of the reason why we did this class is data engineering in the cloud and API integrations. API integrations is a huge part of not just data engineering and data, doing machine learning models, but also this type of real-time detection and analysis. It allows them to obtain that information in near real time. Then there are multiple applications that use it, like ride-hailing apps or taxi dispatch systems. So then they will process the data however they need it in real time. And then maybe they have dashboards, maybe they have some type of detection systems, or they actually send that information to mobile applications that they're processing in real time. So they are like ingesting that information in real time. Then they transform it and enrich it in a certain way to present it, whether it's through Power BI or some other system, app, or whatever that interface might be. So, yeah, the security principles come up next. So I'll let everybody go ahead. I'll get the link out of this video. And let everyone watch it if the link's still in there. Let's just go ahead. I can't seem to pull the link out of it, so let's just go ahead and try to find this in our browser. Let's do, I'm typing it here in my other browser. Real-time, in my other window, intelligence in Microsoft Fabric with sample data. There we go. I'll put this in Slack for everyone. Let's see, this one looks to be a little bit longer. Looks to be about 18, 19 minutes. But this one's a super overview or a super demo. It's really good. So I'm pasting that in here. Oh, 21. It's very much start from end on like framing the problem, the challenge, and then how they ingest data all the way to how they're using it in Power BI and the systems and within Azure and then Power BI. So it's detailed. It is a detailed demo of how it works under the covers, and then kind of like the application within Power BI and how it's used. So let's go ahead, paste that. Okay. So that's a Fabric tutorial. It's 22 minutes. So let's come back at 7:45 after you're done watching it and grabbing a snack. Then we'll do the security piece, which will probably only be about 30 minutes. And then we could cover everything else that we have left here in class. So go ahead and take a decent break here. 7:45 is 22 minutes from now. May just do right after 7:45. They'll start at 7:50, so everyone can grab a snack, but I'll give you a little more than 25 minutes to watch the video and get something to eat. Take a short break, and then we will be back 7:50. All right, let's see everyone then for data and security and wrapping up the class. Let me make sure I gotta get my windows right here. All right, I'm gonna get up and grab a handful of chips. I'll be right back too. See you in about 25 minutes. So, thank you, Gene, for the just-in-time manufacturing. I didn't see it. And inventory. That's a huge use case for real-time inventory monitoring. Can save companies millions. Shout out. Yeah, I won't bother anyone. Just wanted to say I saw that.
Hey, Jeremy, are you talking or are you still not back yet?
Not back yet. I was just cleaning up a couple things. I put this together pretty fast
All right,
today.
I was about to start freaking. I'm like, oh man, I can't hear shit.
I probably should have done it off screen, but it's just making sure like everything, these links were working and everything. I'm just flipping through it. First time I've went through security controls, so making sure it was good. I'll still give everyone a few minutes here. This will be a quick section. Couple videos. I just didn't embed the link in that other one. I can't seem to find it after I embed the link in the PowerPoint. Give everyone one more minute to watch the video. Need to start putting the links underneath of it too. Each one of these. Like I used to be able to click on it. I could just pull the link out.
Hi and welcome to the PowerEgg YouTube channel. In this video, we're going to talk
Okay. We'll go ahead and get started. I gave everyone a couple of additional minutes. I think my key takeaway from the video, you guys see how from start to finish you ingest data and then capture and transform and put it in a pipeline. They even had a KQL type data lake within it. So all the, like a lot of the principles are the same. So you have your ingest, like trying to get the info, all that real-time information, and then how do you process it, and then how do you store the information. So they even have like a specialized data lake within KQL to be able to store data in like a short-term, highly available basis. Then you do those transformations, and then you display it as information. You're just really using really similar principles as we use through the class, just different tools to be able to accomplish it. So kind of a neat section on it, and at the end, taking all that data and turning it into information on Power BI to see the traffic patterns of taxis in New York City and being able to visualize it on the mapping utility in Power BI. Okay. I think I need to quick sneeze here too. Got my salty snack and Diet Coke and ready to go. Right, maybe I don't need to sneeze. All right, we'll start our final section of this class. So data security principles for data engineering. So I was saying offline, this is the first time I've taught the data security principles and the data security part related to Microsoft Azure. It's really, security is kind of like a configuration thing in the class, which we said that we were staying away from, but I had a couple people mention in each class that I taught before about being interested in learning more about the security pieces. So we're going to do a super brief overview. You're likely going to see these principles like in really big organizations with information security teams. Not so much anywhere else. I've worked in big corporations and then medium-sized companies and small. And you never really see like data lockdown like this in smaller organizations, especially smaller organizations, but medium-sized organizations. But maybe you should, because I've heard of data breaches at medium-sized organizations too. So at the very least, as like we've always said through this course, being aware of it as a data engineer and like the security principles and the tools available is then you can start to make better decisions on if the time comes to implement security, on like how do you implement it. But also just as a data engineer, understanding core principles of like encrypting data and moving data in transit and only giving people access to the data that they need to be able to do their job, like least privilege and things like that's important. You may very well do that within a relational database, like an analytical database. But sometimes people they don't need access to everything to do their jobs. It's usually more of like the data analysts or data people were actually working with the data. Being able to make sure the right people see the right data and have access to it. It's important to think about that, even if you aren't directly implementing it as a data engineer. Go ahead and flip to reading view. Okay, so here are core principles of data security or information security that we're going to follow as data engineers. I will teach this in my data engineering class in a little more depth, probably do a full lecture on it, but let's introduce it here. So core data security principles is the CIA triad. So this is called confidentiality, integrity, and availability. So confidentiality is making sure the right people see the right information and nobody else does. The integrity is like if something's generated data, that it has integrity. It's generated from the source that it said it was generated from. And availability is having that data still being available to the right people. So it's really oftentimes the balance between the three. You could lock down everything and nobody would have access, where you can make everything available, but maybe there's no confidentiality or integrity go along with it. I'm going to pop open some of my notes for this. Okay. So defense in depth is multiple layers of security. So think of it as like, I hate to say, I was going to come up with a bad example of like a Mexican border, but think of like North Korea, South Korea. They have like multiple walls of defense and demilitarized zone and everything. So if somebody gets past the first layer of defense, there are actually multiple layers of defense behind it. As we'll see in Azure, it has a couple of different protocols that can be used to have defense in depth. You have the principle of least privilege. This is what I was talking about. Just giving people the minimal access needed to perform their job. So sometimes that shifts and you have to adjust, but not giving them access to the entire world of data. People could potentially do something with it, or it might be sensitive and not really be their business. Perhaps it's like a health record, some information on a health record that you don't want certain people to be able to see. So it can be very valid, especially in the areas of like finance and banking, and then health records, or and HIPAA compliance and that type of privacy. Really being conscientious of it as a data engineer is important. Having least privilege. So data classification, that's categorizing it by sensitivity level. So, perhaps there's some data that's way less sensitive than others. You can think of that as just the example we talked about as far as somebody's patient records and their social security numbers and stuff like that. Probably be the highest priority or sensitivity. The lowest priority may be Probably not sales leads. That would be like medium sensitivity. But something like, like a systems list or something like that, being able to see all the systems in the company. Like some type of information in like a data warehouse about that. Like maybe you actually want a lot of people to be able to see it. So classifying data to that sensitivity level helps you with some of these other security principles too. And shared responsibility model. So the ability to divide security duties between parties. So this is like, instead of just one person overseeing an entire system, having multiple people be able to divide those duties. It's kind of like the more eyes you have on something, the more that you'll be able to see like potential errors or failures in data security and information security. So there's a video. And I think, let me see if I can pull this up real quick. I just had it up. Yeah, so it will talk about these principles and some security and some information in transit and so forth, just information security in general. It's kind of general, so I will just put it in here. It covers more than just probably what a data engineer would talk it or be concerned about. I'll keep moving forward and let everyone watch that one at the end when we have time and we get through all the questions for the class project and for the class project and exam and so forth. Okay. So keep these in mind. I'm going to highlight each one of these as we go through the different Azure security components and how they apply to confidentiality, integrity, availability, or defensive depth, or least privilege, classifying data, or shared responsibility. Okay. So security control types in data engineering. This is like a classification of different controls that you can put on data or systems. So you have preventative controls, you have your authentication, encryption, and network security. So these are ones that prevent access to be granted or not granted to people. It keeps the wrong people out of the systems and the right people access to the systems. You'll notice authentication from the REST APIs. So that's what the API keys are, or different authentication protocols. Is that basically it's granting you access to, if it's a REST API, like Box or Live Coin Watch, it's granting you access to the set of resources or endpoints that it would like you to have access to. So it thinks that you should have access to. Same way with encryption. So you encrypt data. Oftentimes as you transmit it or you have it at rest when you're storing it to prevent people from being able to access that sensitive information without like decrypting the data. And then network security. So you have network security controls that keep people out of networks and systems. Those are probably the most common types of attacks on companies or network attacks. All right, so you have detective controls. This is the ability to be able to detect these types of threats as they happen. So you have logging, you log all the different events within a system. A lot of them will be okay events, but sometimes you would have things that aren't, but you log all of these anyway because you end up monitoring and you end up monitoring them for any type of threshold or things that are outside of expected behavior, just like we learned in real-time data, doing that with fraud detection. You could also do that with network security or information security. And then data access auditing, so continue to make sure the right people are accessing the right data. You have corrective controls, so you have how you respond to different types of events or incidents. And then your backup recovery, so you can, if there's a network attack that locked down your network, you could go back in time to when it actually worked. That is huge, like disaster and incident and disaster recovery at a big organization. Imagine a Fortune 500 company and all of a sudden their systems were all locked down and they couldn't go back and do any of their work or recover any of it. They'd probably like literally go bankrupt, or maybe not, like not even be a business anymore. That's how important those are. Identity and access management. This would be like IAM would be like being able to identify yourself as the person that you are actually within a system. So this might be using like Google Authenticator or some type of personal token or identification, probably even, your personal ID to identify who you are and who you say you are and the access that you should have. And then data protection methods. So encrypting it at rest, in transit, and in use. So encrypting it at rest and in transit are very common. I talked about that when we were talking about preventative controls. So when something's being transferred over a network in transit, it can't be intercepted by somebody and then that information stolen without the key to be able to decrypt it. And encryption at rest would be if someone broke into your network and they were looking through your files that were in your network or your data lake, is that they're all encrypted when they're there, so they couldn't just take it out. Very much less I've heard of encryption in use. I'd have to think about that. I guess this would probably be, it's not really encryption, but it's stuff like with HIPAA data, you may take out sensitive information like personally identifiable information of that person, like their birth date, their social security number, their name, things that could personally identify that person. Not really encryption, so I have to think about that one. I'm actually interested enough just to bring it up on my web browser. Okay, how does encryption, okay. Encryption works by encoding plain text into ciphertext, so that's encrypting it, and that doesn't tell us a whole lot. I hate these definitions. So we'll go to ChatGPT. Okay, encrypting data while it's actively being used in memory. Even if data is encrypted in rest and in transit, it's typically decrypted. It creates a vulnerability if an attacker gains access to system memory. Okay, so this is like if you're actively using an Excel spreadsheet. Well, Excel spreadsheet is probably not even the best. If you're processing data and it's in memory, it's encrypting it until you use it, until you process it within memory. So just in case someone would hack into your or have access to memory and steal out of it. I have a really hard time thinking that someone would do that. I've never heard of somebody doing it, but I guess it would be a thing. Maybe a website that was holding customer information actively, and you encrypt it in memory until it's used by the website. That might be something. That might be a use of it. Okay. So security in Azure overview. So this slide is a little bit out of sorts. That's an overview of the security principles in Azure. So the purpose of Azure security is a unified security model to protect resources and the data across the entire ecosystem. So you've heard the term resources. That's what we created, like the little applications like Data Lake or Azure Synapse Analytics. And then data across the entire ecosystem. So whether it's in the Data Lake or moving across the pipeline or being stored in a relational database, it's that unified security that meets those other principles that we talked about. So some of the key components, Azure Active Directory. So if you've ever heard of Active Directory, it's Microsoft and how they create users and subscribe roles to them and everything, permissions and roles and so forth. It is built on top of that Microsoft Active Directory. This is inside of the cloud. It serves as Microsoft's IAM, the Identity and Authentication Management Foundation. Let's see what else we have. We have the foundation is built on Azure Active Directory. We talked about that. Within this, we also have network security. So we have virtual networks, firewalls, private endpoints. You can do a lot with network security. We talked about that as part of the infrastructure that we want to secure. We can protect data. We can encrypt it, manage your keys. That's what we originally tried to do with the Key Vault, is like we tried to manage that API key that we got from Box, or we got from Live Coin Watch, but it ended up being painful, so we went away from it. Monitoring and compliance, being able to track everything, supports all the security principles, enables regulatory compliance. So healthcare and finance being the biggest ones. Okay. So we're gonna now evaluate the two main types of security controls within Azure. So we have role-based access control, and then we have access control lists. They have two different purposes. So we're going to highlight that here. So role-based access control is the one that you would use the most in Azure. Oops, wiped off my keyboard. So it's the one that you would use the most within Azure. It's how you assign different roles to users. So we just talked about that with Active Directory. It's like Azure Active Directory. And that's really what it is. It's Azure Active Directory. And then you can assign a whole bunch of different types of roles to a user, and even different roles depending on what resource they can configure. So they could have different roles in Data Lake versus what they do in Azure Synapse Analytics versus what they do in Machine Learning Lab and so forth. You can really customize it into a different role, into different roles and what they are allowed to do. So it implements, so these controls, if we remember our principles, they implement principle of least privilege by assigning only the required permission to resources. They serve as preventative controls by restricting unauthorized access to different resources or data, supports confidentiality, integrity, and availability by enforcing confidentiality through controlled access. So only the people who need to see the data can see it, and defensive depth. So it's just one of the layers of security in Azure, along with Azure control lists and encryption and so forth. Okay, the key components are the security principle. It's who needs access, users, groups, and service principles. And you won't know what service principle is. It's like who has access to, or who does what within each one of the services or resources. This is where the configuration in Azure gets really challenging. Role definitions and what can they do? What's their scope? So can they do it at the subscription level, the resource group level, the resource level, and so forth? So like what level do they have that access to? And then their assignment. So are they like an administrator? Are they a user of it, a viewer, or do they have some type of access? Maybe they're a creator within some type of resource. Those are their roles, their principles, service principles, and their scope. So to get a better explanation of this one, I'll actually give everyone a chance to watch this. It's 7 minutes long. We'll do this until 8:28. So I'm going to put this one in Slack. And I'll give you a feel for how this is configured. And legitimately, why I don't cover this so much in class is because this whole configuration and security isn't just necessarily for just the data platform. It's the entire Azure platform, and their full courses within the Azure within Azure Learn, whole certification courses on just access control within the entire Azure ecosystem. So to have it as a focus of it, this would just take up an entire class, and not what people are here for. But once again, having familiarity with it is important. So I have put that link there in Slack. Go ahead and watch it for 7 minutes. We'll be back. We give everyone till 8:28 to watch it. Be back in a few. come back here in 2 minutes. 8:28. Just over a minute now. And then a second, we'll get rolling through the rest of this course content. Okay, 8:28. Let's go ahead and get restarted. Make sure I bring up the right window here. Okay. So a couple takeaways from this one. One kind of funny observation is that we saw every single one of this guy's beard and hair combination seasons all in one video. He's actually relatively clean cut here. And he's kind of a wild man in this video. And then he's like patchy shaven in the very last video. But besides that, very simple video showing how I set up a user in Azure AD and then assigned role-based access to a resource group for that user to be an owner and be able to delete the resource group and do whatever they wanted with it. What they don't show is how complicated these relationships get within Azure sometimes, especially when you're a service principal or a user security principal who's trying to like connect between two services. Like you're trying to connect services together, like data from the data lake and then it to Databricks or something like that. So that's part of the challenge is like when we had to write special code to be able to grant our user or a user and service principal access to the data lake and that data file is that it can really get challenging sometimes and difficult to configure. But of course now you know, and knowledge is power, I think. So yeah, it's definitely a configuration task, but having a basic understanding of it puts another notch in our tool belt. Okay. So then the other type of access control, it's called access control lists. And these are really used on like file and folder level permissions within blob storage or file storage. And then of course, Gen 2 data lake storage within Azure. So what it does is it provides fine-grained permission control at the file and folder level, enable data-centric security independent of resource management. So an example here would be is if you had this data lake, maybe it's Contoso store, and then one of your folders is my container. you could go into that and set access to certain users in the access control list, and then give them different default permissions to read, write, and execute your folders. So if you've ever worked with, I don't know if that many people would have worked with Unix in this class, but you can set different file permissions, read, write, execute, to be able to do those type of things within files and file systems. So what's important, what principles this follows is least privilege at the data object level. So even down to the file level, you can set these permissions. Defense in depth, it adds an extra security layer to role-based access control. It really allows you to fine-tune your access to very specific data sources, folders, and data sources. So remember, two of the things that we talked about with security is how you access resources, and then the other is how you access the data. This is more about like accessing the data, whereas role-based access control is more about resources and resource groups and users and what roles they serve within the Azure data, within the Azure platform. This is specifically related to data and files. So it's another layer of security, supports data classification by enabling different controls for data sensitivity levels. I haven't done that before, but I assume that there's a setting in here that you could automatically configure default permissions. There are probably different sets that you can do there for different sensitivity levels. Enhances confidentiality by restricting access to this specific files. So its key characteristics, it POSIX compliant, so you don't have to know a lot about that other than it's a read, write, execute. You have two types, access ACLs and default ACLs. More granular than role-based control for file system objects, so very useful for, the role-based controls can only do so much as far as like, are you administrator, owner, user? They're kind of broad. These are very specific to files and folders. Permissions defined for owner group, named users, etc. You can define it a bunch of different ways for different users, primarily used in Azure Data Lake Storage Gen 2. Okay. So short use cases, go through this really fast. So for RBAC versus ACL on the role-based access control, what you could do with it is manage the platform. Say your DevOps team configures Data Factory with a contributor role. You give the DevOps team access to Data Factory. You can control costs. The finance team can be a reader role to see how much a resource is being used and how much cost is being associated to it. Might be useful. There's also a cost management module inside of Azure. You may give them access to be able to see like what the overall cost is. So department isolation. So assigning storage account contributor to each business unit for their own storage accounts. Perhaps for oftentimes you'd want a silo for what marketing is doing versus what finance is doing. In general, the idea of more and more you want to like democratize data and spread it out over the organization, but sometimes that's not necessarily a reality. So you give people different levels of access, what they need to do their jobs, more or less, instead of making it across the organization. Usually you decide what you want to make organizational-wide data and information, at a big company at least. Pipeline operations, so assigning a Databricks role to an automated system. You get to assign it to a process. And compliance monitoring. So security reader role. Audit team can see security reader. They can see the security control set on all the different resources. So ACL use cases might be a data lake, multi-department data lakes where you want just a department to be able to access those files. Personal identifiable information data protection. So did only certain users, say within a hospital, can see the actual patient record and like patient specific identifiable information. Maybe you have a sandbox environment. You just want the data scientists to access certain things and not have access to systems or applications. That might be a reason. Financial data is usually the most sensitive. You don't necessarily want to share it across the organization. And then the ability to data share. All right, so that's the content for this class. Hopefully that gives a good overview of security and the different types and the principles and the two main protocols within Azure. I think that's good enough for this class. So the rest of the content in these slides are just bonus course things I put here. As to remember the entire ecosystem, it's actually much bigger than the data platform itself. There are all sorts of different modules in here. Some of them are data related, some of them aren't. Some of them are operations, some of them are AI services, Power BI, Office 365. It's all highly integrated. Here's a highlight of the data platform within the Azure services. More information about the security exams. So we started out doing 203, but then we realized that's a ton of configuration on top of what we're learning in this class. 900 may be the more practical exam. So integrating, transforming, and consolidating data from various structured, unstructured, and streaming services. We didn't get a ton of hands-on in this class, but it would be a nice like continuation, I think, from the skills that you learn in this class. It's a beginner level data engineer, Microsoft certification. And you do some relational and non-relational data in different workloads, types of workloads. It would be a good jumping off point from this class to continue to learn more is a DP 900. And then there's a Fabric Analytics Engineer. If you're interested in Fabric, there's a certification for that too. This should be more related like the data fundamentals, less configuration, but kind of a busted up platform in my opinion. So I'd probably wait on it unless you see a lot of job postings and that people want Microsoft Fabric engineers. Let's see. Go ahead and look this up real quick. We'll go to everybody's favorite, LinkedIn. I don't think I personally really seen that many. Maybe there probably is. See all job results in the United States. I don't know how many companies are using Microsoft Fabric yet. If you're like a lead and they already have the platform, if you do data modeling, you do data warehousing. Data modeler with strong Microsoft Fabric. Okay, let's just do Microsoft Fabric. I don't want to take up too much time here. Data modeling, data engineering. There are probably some specific roles you could maybe get into. You have to look hard for it. Perhaps they give you your niche somewhere, or you could go learn it on the job, maybe, probably even better. If you're whatever company you go to decides to go to Fabric. Your subscriptions, so more information about your subscriptions. They should come to expire here really soon. There are some free services that you automatically get, and these are some of them here. But the other ones, pretty soon Microsoft is gonna ask if you want to move to pay-as-you-go pricing. You probably don't want to do that because you'll continue to get charged for what you've done in Microsoft Azure. Say they will not charge you unless you decide to move to pay-as-you-go pricing, and you could always cancel and delete your subscription. So you have 30 days to use that $200 in Azure credit. So it's coming up right here at the end. But you still get some of these free services. Like you could still have Azure SQL DB if you wanted for 12 months. Or blob storage. I don't know that if it includes Gen 2 data storage or not. But just a heads up on when you signed up for it, you can cancel or delete. That's probably what I do. But if you want to keep it around and turn it down to the lowest resources, it probably only costs you a few dollars a month to do that. Hate to say it, and it costs more, but you could look at it and manage it and play around with it a little more. And I've played around with it for just maybe $10 a month if you turn everything to its lowest setting. A slide about future data engineering and AI. Oftentimes you don't go straight into data engineer. Maybe you were a data analyst or a developer somewhere. But oftentimes I found it was just me gaining more responsibility within an organization, and more had to do with being able to manage data. So you build the skill set more than more. Oftentimes I recommend to people getting into data. It's probably usually best if you're just within some organization and somebody needs to do their role and you raise your hand for it to be able to get into that role, data engineering. But if you have a certificate and you go out there and find some jobs, likely you'd find somebody. You could be an entry level data engineer, especially if you have some type of development or data background already. Okay, so data engineering skill set, I put that here. We covered it. I think we actually covered it pretty well in this cloud, being able to visualize data, knowing different platforms and the tools at your disposal, being able to work with different types of data to turn it into information, even real-time data, and then knowing programming languages. I think we covered it pretty well in this class. And doing it as a career, the difference between database administrator, engineer, and analyst. So engineer is really like the person who is building like these pipelines and systems to be able to continue to make things work. Whereas a database more focused on like the database system itself. They're more like a system administrator and database administrator, like permissions and things. Or data analyst is really just focused on the data mostly. Data engineer is kind of like the backbone of data in an organization, I think. And that is it for all the slides. Covered a lot in this class and even shifted gears. Anybody before we cover anything have questions or about course content? I'll give you an opportunity during the final to ask feedback on what else you would like to see in the class. I'm more than happy to take that. But I'm glad more or less we shifted gears and covered what we could here. And if there are any thoughts, let me know.
I'm good on my end, boss man.
Okay. I don't know what I'm expecting here or anything, so feel free to leave them in the. It's hard to get put on the spot and everything, so feel free to leave them. It's like the final questions of the final exam. How was your experience? What did you learn? What else would you like to see in the course? I think one of the things in this course we could still do is more hands-on work and continue to figure out how to incorporate that. Thinking of that, so that was one of the things I did this weekend. I'm still waiting for all these videos to upload. My connections has been overloaded, but I did. Yep, there's Verizon telling me I'm almost out of data. I use my Verizon, like not hotspot. It's like a wireless internet hub, but I put it to the test and I hit the data limit and everything with all these videos. So I should go back to fiber, but I've been fighting paying for it. But let's see. So one thing, quizzes. I'm not sure that I released all the quiz scores to everyone, so I'm going to go back through and do that. I think maybe they haven't all been released to everyone, quiz 1 and 2. I'm going to do that before so that you can use those to study for the final exam. You're going to see some familiar questions there too. They almost probably word for word to remind you of just to remember some of the concepts of what we did in the previous classes. So I spent this weekend going back through each one of the hands-on exercises, and I did videos, and I still need to paste links to all these videos. But the first one was class setup, and I did put the hands-on exercise there. The second class was working with the Box API, and I had a video from the first class. It uses desktop Postman instead of web Postman, and it configures a little bit differently, the desktop version versus the web version. But if you download the desktop version and go through this walkthrough, you should be able to do it. And then if anybody wants me to record the web walkthrough, I can still do that. But I did update the hands-on exercise, class 2, the class 2 hands-on exercise. I went through it and got it working in web Postman, and it reflects working instructions in web Postman for the Box API. Let's see what else we have. So class 3 and 4. So class 3, I just have this one focused on putting the overall crypto history fact table into the data lake, and then importing that. Well, then using the SQL on-demand pool to query it and visualize it. So that's class 3. Class 3 was about storage. So you put the CSV file in there, and you can query it using SQL on-demand pool without loading it into a table. It has those instructions. I do have a video for that. I used Data Explorer in the first class. So Data Explorer, we learned about that today. Then you can do something really similar because you can query files in the data lake using Data Explorer. But this one is for SQL, for the serverless SQL pool, like we learned about in class. So I still owe a video there. Class 4 will be about creating a pipeline to take the JSON file that you get from the REST API and then storing that in SQL Data Warehouse. So my video that I have for it, I used, it's also from the first class. we used Azure Data Factory, but you can also do this within Synapse pipelines. So the Synapse, Azure Synapse Analytics, that resource that we installed, it also has Synapse pipelines. It's a little bit more of a reduced version of Azure Data Factory, but it'll work fine to create the pipeline in there. Create the pipeline that from the JSON file on the data lake into a table, storing it in SQL data in the SQL data warehouse. So these will also provide valuable because they're direct examples of things that you'll do in the class project. So if you're stuck on it, you could go back to one of these videos and hands-on exercises and kind of walk through them and see how they're done. Then class 5 is a Synapse pipeline. This is where we connect directly to REST API to the SQL data warehouse. My first video was doing this with MySQL. We used MySQL the first time, but you can do this with SQL data warehouse. And it's directly applicable to completing that pipeline and getting data from the Live Coin Watch API and loading it into the table. So class 4, I would say, is taking that initial JSON file that you get out of the response from your overall history endpoint. And for the class project, don't worry about doing a bunch of different coins like Bitcoin or Ethereum. Just take a look at that overall history endpoint and just try to predict the overall market cap for this class instead of doing it for a bunch of coins. Or if you want to do a single coin, that's fine too. But I'd just narrow it. I'm just narrowing it down so you don't get overwhelmed and build a bunch of different models and things like that. We just focus on predicting overall market cap. So 5 is like where you start to connect to the API to automatically refresh the data in the table, and you schedule that pipeline to update every so often. And then 6 is the video that we did last Wednesday. It'd be last Wednesday, where we did the machine learning model and data IQ with guided walkthrough. This guided walkthrough, once you complete the other steps, the hands-on exercises, so you have that data loaded into in the SQL data warehouse, you can connect these instructions connect data IQ to that SQL data warehouse to be able to get that data. And then the multiple steps in here from exploring the data set and preparing the data set, creating features, creating the models, and deploying it by API. Like I did in the video last Wednesday. So I think once I get all the videos posted, then you'll have walkthroughs for pretty much all the steps that you need for the project. So nothing in this last lecture will be included. You'll have to use to complete the final lecture, whether it's security or real time. Just content that we learned in lectures 1 through 6 and complete the class project. However, we will have some light questions on the final exam about real-time data and cloud security. So just thinking about it in my head with like security, it'll just be like, what is role-based access control? Maybe it's a multiple choice question. And then like, how would you use it? I'd give you a scenario and like, how would you use it in that scenario? But maybe not even that. I have to think about it. Basically what it is and how you would use it. And maybe an aspect or two of it, but not that much more than that. And then real-time analytics. maybe like what different technologies are involved and when would you use each. I forgot what the questions were on the exam, but that's the idea, is that you have your concepts here and then you apply them in Azure, and then how do you take those and apply them in real life? And I think that you're off to a pretty good start. So like understanding like the concept, how does it work in Azure, then how you would use it to solve a problem, then within their job function. Does all of that so far make sense before I cover really quick the final project? Any questions? I still owe everyone the videos. I just need to get all the way downloading them and provide the links. Have to go. If anybody knows of a good coffee house with awesome broadband connection, let me know. Wouldn't mind going there at all. Okay, so last few minutes, let's cover the class project. So I did the class project in favor of homework 1. We just got hung up at the beginning of class, so we'll just do this pipeline, this cloud machine learning pipeline from start to finish in one assignment. And I feel greatly simplified overdoing each one of them separately. So I dropped a note in there. If you completed homework 1, if you completed it, go ahead and send it to me. I'll give you credit for it and look over it and provide you feedback. Otherwise, if you started it, it will help you on the final, because that's where the class project, because that's where the class project begins. So basically, it's like a combination now of classes 1 through 6 and the homeworks related to those classes, all within the same project. So let me, as I'm talking, can't talk and find this at the same time. Let's go ahead. And I even created a walkthrough guide. So more or less, like, the class project is like a higher level overview. So it's project overview, and your learning objectives, what the objectives are of the project. How I'm going to relatively grade it. It'll mostly be pass fail, but what weight I give to each section. So if you think of this end-to-end pipeline, it's your data collection or ingestion first. So creating a Python notebook in Synapse Analytics that connects to that API, gets that data back, gets that response back for the market overview data, stores it as a JSON file, and you could run it daily. You schedule that notebook and in a pipeline to run daily. Then you have your data processing pipeline. This would be a Synapse Analytics pipeline, so like a data factory pipeline, where you load that JSON data into the SQL pool. You create the table for it for analysis. You can schedule it daily, and it refreshes with new REST API data. That's what I'm looking for there. So this one's like just an initial download of the data. That's usually where I start, is that I do a one-time download, and then I create the tables, and then I develop the process that refreshes the data in the database table. So once you have that database table, then you can create that model in Dataiku that connects to the Synapse SQL pool. So that's where the guided exercises can help too. You can see the guided exercises will lead you up to this point. And then you can connect to that table, do some feature engineering, build your model to predict the 7-day future market cap, deploy it as a service, and then visualize and monitor it. You can just create that dashboard in Data Haiku. If you wanted to create it in Power BI, you could, if you want to take that step, but the dashboards in Data Haiku are okay. If you create dashboards to show your market cap over time and what the prediction looks like over the next 7 days, and like model accuracy, statistics, and stuff like that. The walkthroughs can help out a lot, especially what we did with Data IQ Class 6 will help you do those steps. And then the videos leading up to that should help also. Feel free to partner up however you can with other classmates. I'll make this class, this will be due on the 11th at midnight, so I can grade it at 12. So I can grade it on the 12th, on Monday the 12th. So next Monday, and provide you feedback. So you have a week to complete, almost a week to complete. Any questions, concerns about the final project? I tried to get it down to just the bare bones that we needed, like the core of what we wanted to accomplish out of this class. Now it's kind of your turn to take what you learned and go hands-on with the projects. If you get stuck anywhere or something doesn't make sense, just let me know in Slack or by email. Put some time and effort into this one to make it the right project. The other one is the other document I should show. It'll give you more, if you get stuck where you're going through it, more of like a step-by-step of each one of these parts, of like some code that you can use, the endpoints that you should be looking at. So think of it as like breadcrumbs. Think of the other one as breadcrumbs to completing the final project. Testing your data collection setup. One of the value things is here's the table that you can set up in your SQL data warehouse. I did that based off of that CSV file, created it off the CSV file. And then steps to create your Synapse pipeline, do your feature engineering and so forth. And then a checklist to verify that you completed the components. So use this alongside of as you're going through the project as kind of like a guide if you get just lost on what to do. Thumbs up from everyone. Questions, concerns? I will be here on Wednesday. I dropped that note. Anyone who wants to come down here and work on in person at Elevator, I'll be here if you want to work side by side and help you through things. Just offer that. Everything clear? Questions? Here for a little while, so let me know. If you're already working on it, that's awesome. It is kind of late though. It's looking like everyone's getting to work. Dropping the, I'll imagine getting to work, probably going to sleep.
All right, sir. Thank you so much. Um, it's clear for now for me, but I'll get my hands dirty. And if I'm stuck, I'll reach out. But I appreciate it though.
Yeah, I should just say do your best too. And if you
Yeah.
get stuck, it's okay. And then at the end, we'll just see where everyone's at.
Thank you so much. Appreciate it. And you have a good night.
No problem.
Yeah. Thanks, sir.
See you Wednesday.
All right. All right, boss.
Bye. And that concludes this class. It's been a good one. The little few bumps and lessons learned, but it's the end of the class for course content for cloud solutions and API integrations, covering this content here in the syllabus, lightly covering big data and real-time analytics, but otherwise accomplishing the goals. And now all we have left is the final exam and final project. And this is Jeremy Bergman, happy to teach this course. And for Omaha Data Science Academy, signing off. Thanks, everyone.